Hello, welcome to my first ever recording. So you're probably going to hear me say okay, all those things you're not supposed to say. I just want to get through this and probably I'll do the best that I do. Today we're going to be talking about graphing proportional relationships. You guys should be following along, right along with me, filling in the notes, pausing the video, and trying examples on your own when I tell you to. Just to remind ourselves, graphing proportional relationships, and we talked about it back in the fall. We talked about graphing through the origin, making a straight line, which is going to come out later in the notes today. But for right now, we just want to remind ourselves how to graph proportional relationship comparing x and y. So this graph is already semi-filled out for us. They're telling us where the gains purchased on the x-axis will go. They're telling us where the total points for the y-axis will go. And they're looking at the number of video games. Number one is saying that a video game store has a frequent shopper program. You earn 4 points for every video game you buy. Draw a graph to model the situation. You need 48 points for a free game. So how many video games do you need to buy to have enough points for a free game? So we have to go along and think about what our scale is going to be on our x and our y axis. So I say to myself, well, I buy one game, I'm going to get 4 points. 2 games would get me 8 points. 3 games, 12, and so forth. So I'm thinking about a scale that would work over here, starting at 0, and I'm going to just go up by 2s. So I'll have 2, 4, 6, 8, 10, 12, 14, and 16. Then I need to match up on my y-axis that if I bought one game, I get 4 points. 2 games will get me 8 points. 4 games gets me 16. And so forth. I'm just going to keep going up by 8. So 8, 16, 24, 32, 40, 48, 56, 64. And then I will just kind of plot my dots. So 2 games, 8 points, 4 games, 16 points, 6 games, 24, 8 games, 32, 10 games, 40, 12 games, 48, 14 games, 56. The question says that you'll need 48 free points to get the free game. So if I look where 48 is on my graph, the corresponding x to that will be 12. So that tells me at the point 12, 48, 12 games will get me 48 points. So my answer will be 12 games. Moving on to example number 2, I would like you guys to try this one on your own. So pause the video, try this on your own, and we'll go from there. Okay? So hopefully you were able to get a graph out of this one. Your school is selling raffle tickets as the fundraiser. The raffle tickets, again, are sold in groups of 4 for $3. Draw a graph to model the situation where the horizontal axis is the number of raffle tickets purchased and the vertical axis is the total cost. Which again, this is nice for us, they've already labeled the graph. So that helps. So I started off at 0, I had 4, 8, 12, 16, 20, 24, 28, 32. And then I went up by 3s on the y-axis at 3, 6, 9, 12, 15, 18, 21, and 21, I had 21, 28. That's my dot here. If I have $21, divide that by the $3 that it costs, that's going to get me the bundle of 7. So 7 times 4 will get me 28 raffle tickets. The next page, you really don't need to write anything on here. This is more of our key concept that we talked about again in the fall, reminding us that what makes a graph a proportional relationship. And you have a table which shows a proportional relationship where one quantity is a multiple constant, multiple of the other. We have our graph, which will show us the straight line going through the origin. And then we also have the equation, and this is the one that students tend to forget about, that the equation in the form of y equals mx represents proportional relationship. M is the constant proportionality, or remember we would also call that our unit rate, which when you solve for m in y equals mx, you also get y divided by x. So we just always want to remember that if we have y equals mx, if we solve for m, y divided by x equals m, which means that would also be our constant of proportionality. Example number 3 states a salesperson earns a 10% commission on sales of energy efficient appliances. Draw a graph to model this situation. Is the amount of commission proportional to the amount of sales? How do you know? So I like to organize my information by using a table here. I know that sales is on my x-axis, and the amount of commission money is on my y-axis. So when I set up my table, I will have my x, which is the sales in dollars, compared to my y, which is the commission in dollars. Scroll that down. First, I kind of need to figure out how much the salesperson, if he gets a 10% commission on the sales of energy appliances, I know that if he sells $100 worth of items, he's going to get 10% of that, which is going to give me 10. If he sells $200 worth of items, he will get a $20 commission. If he sells $300 worth of items, he will get a $30 commission, $440. Notice I don't have to put the dollar signs every single time because I already put the label within my title. So we're going to go through and set up our graph. We start at 0. I know it seems kind of silly to put 0 here because 0 in sales gets 0 commission, but we need to just make sure we know where the origin is located. So to use most of my graph, instead of going up by 100s, I'm going to go up by 200s, but I'm going to skip a box every time. So I'll go 200, 400, 600, 800. I like to put the dashes if possible because then I know exactly where that is falling. Then I do the same thing. I'm going to skip 2 boxes, go up to 20, 40, 60, and 80. Sorry for the constant moving of the screen. Then I plot my points. So I've already figured out that 100, which will be 1 space over, I'm going to get $10. Plot my point. 200, I'll get 20. 300, I'll get 30. 400, I get 40. Since this is a graph, I'm going to continue. I'm going to draw, connect my dots, and continue off in a straight line. I put an arrow at the end of my line. And so they're asking, is this proportional? And I would say yes. The graph is a line. That passes to the origin. Now go ahead and try number 4. Perfect time to pause the video. Okay, hopefully you guys had enough time to get through that. You should, because you can pause at your own pace. Number 4 was talking about the paying 14% sales tax. I already helped you by setting up a graph here. We want to remind ourselves that 14% is the same thing as 14 hundredths. So if you wanted to find 14% of a number, you would just multiply by 14 hundredths. So if the cost of the car is $50, I would have a $7 tax. If the cost of the car was 100, I would have a $14 tax, 150, 21, 200, 28. I set up my graph here. I went up by 50s every other, so 50, 100, 150, 200. I like to use as much of the graph as possible. Then I went up by 7, 14, 21, 28, and you can continue going up by multiples of 5 if you'd like. The graph 7 is at 50, 100, that, 150, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200, 200 connect my dots, and put my arrow. So they ask again, is this a proportional relationship? So yes, it is a line, same explanation as before, that passes through the origin. Now I'm going to do the next one with you because the graph looks a little bit different than what we're used to here. Instead of, oops, sorry about that, just like being in class. Okay, this is telling us that we are going to have some negative values. That's why our graph would be going this way instead. So our x might still remain positive, but our temperatures could be going negative. So they notice where they have the label for the x-axis is actually up here now. So this says ice forms at 0 degrees Celsius. The surface temperature of the ice on an ice rink decreases 0.5 degrees Celsius every hour. Draw a graph to model this situation. Start when the surface temperature of the ice is 0. And then of course we'll be asking, is the surface of the temperature of the ice proportional to the time? How do you know? So I'm starting to set up at 0. So I've got my x and my y. X is the time, y is the temperature. They told me to start at 0 on my graph, but obviously if it's at 0 degrees, we haven't started with any, time has not passed yet. So then I will go up in whole increments in my x, go 1, 2, 3, 4. And if it decreases, that means that it's going to be a negative. So if the time is 1, the temperature will be negative 0.5. I'm looking at my time here. I seem to already be going over, so I'm hoping to stay in time. 2 will go to negative 1. 3 goes to negative 1/5. 4 goes to negative 2. So we're on a graph. We start off at 0, 0. And go 2, 4, 6, 8. And then I will go 2 spaces, negative 1, negative 2, negative 3. Again, I just like to put the dashes because then I know which box I'm at exactly. We're at 0. Negative 1 was going to be, we matched up with 2, which meant that after 1 hour it was a half, so we put my point here. I keep going down a point. Connect my lines. And even though this is a straight line that is going in a negative way, it's a straight line passing through the origin, so it is still yes that it is proportional. And how do I know? Straight line passing through the origin. And our last example, this is going to be again very similar. Go ahead, give this one a shot. Okay, hopefully we have enough time again. Number 6, we're filling again the chart in. So I went to have my time of 8, 16, 24, and 32. The position was negative 10, negative 20, negative 30, and negative 40. Set up the graph, 0, 8. For the magic of television, I'm going to pause this and finish. Okay, I'm back. So there's my graph that is finished. And then again, they're asking, how do I know? So I say yes, straight line passing through the origin. So I survived, and hopefully you did as well, my first recording of a math lesson. Have a great night, and I'll see you tomorrow.